to Decarbonize, the clean energy podcast from Fresh Energy. Fresh Energy is a Minnesota nonprofit working to speed our state's transition to a clean energy economy. My name is Jo Olson, and I'm the Chief Communications Officer at Fresh Energy. Today, we're sharing a recording from our May 14th webinar about policy pathways for decarbonizing the manufacturing sector in Minnesota. Let's dive in. So hello, welcome to our webinar. It's called Policy Pathways for Decarbonizing the Manufacturing Sector. It's co-hosted by Fresh Energy and the 2035 Initiative at UC Santa Barbara. My name is Jo Olson, and I am the Chief Communications Officer at Fresh Energy. If you haven't heard of us before, Fresh Energy is a nonpartisan, nonprofit clean energy advocacy organization aiming to shape and drive bold policy solutions to achieve an equitable, carbon-neutral Minnesota and Midwest. So before I pass the mic, first, yes, this webinar will be recorded. If you have to leave early, don't worry. We'll send you an email with a link to the recording probably tomorrow morning. Second, some of you submitted questions ahead of time when you registered. We love that. We'll be getting to the questions at the end. But if you didn't submit your question ahead of time, please use that Q&A function on Zoom. It's at the bottom of your screen. Just click the button. You can fill in your question there. And if you see other people's questions that you like, you can upvote them and they'll rise to the top of the list. Now, I'm absolutely thrilled to introduce Dr. Leah Stokes, who will be guiding us through today's conversation. An expert in climate and energy policy, Dr. Leah Stokes is the Anton Vonk Associate Professor of Environmental Politics at UC Santa Barbara and author of the award-winning Short-Circuiting Climate Policy book, which examines the role that utilities have played in promoting climate denial and rolling back clean energy laws. So currently, Leah's finishing her next book. It's called The Carbon Wave, and it's set to release this fall. It tells the inside story of how the largest climate law in American history was passed. So Leah, thank you so much for joining us. It's been a few years since you were a keynote speaker at Fresh Energy's Benefit Breakfast, and we're really excited to be doing another event with you today. Welcome.
Yeah, right back at you, Jo. It's been so wonderful to be partnered with Fresh Energy over so many years, and we're really excited to be releasing and launching this report today about advancing industrial electrification in Minnesota. We have some really awesome people for you to hear from, including some intro remarks from Pete Wyckoff and Kate Knuth. And before we get to that, I just want to give you the agenda for the today. So we're going to do welcome and introductions. We're going to have those intro remarks. Then primarily Eric Massenet, myself, and Nate Mariano will go through the report overview and the findings. And then at the end, there will be time for questions. So if you have questions that you'd like to ask about other things that we found in the report or things you'd like us to look into the future, we're happy to take those questions. And then we'll be closing it off for the day. So really excited to have you all here. And with that, I believe I'm going to pass it over to Brandon, who is going to introduce himself briefly.
Yeah, thanks so much, Leah and the 2035 Initiative team for all the support here and joining us for this webinar today. I'm Brandon Isaacson. I'm the Managing Director of Industry here at Fresh Energy. Came on about a year ago to spin up our industry and agriculture programs and thinking about the low to medium temp heat opportunity, clean heat opportunity. I've been really excited to work with the 2035 Initiative team. And with that, I'm just going to pass it over to Eric.
Thanks, Brandon. Hello, everyone. My name is Eric Massenet. I'm a professor here at UC Santa Barbara in the Bren School of Environmental Science and Management and also in the Department of Mechanical Engineering. So here at UCSB, I lead the Industrial Sustainability Analysis Lab, where we develop models and data sets to really shine a light on the opportunity space for different industrial sectors to achieve sustainability goals. And I'm really excited to share some of our results with you today. And with that, I'll pass it back over to Leah.
Yes, and now I have the distinct honor of introducing one of my friends, Pete Wyckoff. Pete is a superstar. He is also the Deputy Commissioner of Energy Resources at the Minnesota Department of Commerce, and he was appointed to that role in September 2024. He's an environmental scientist by training and an emeritus professor at the University of Minnesota Morris. He holds a PhD in ecology from Duke University. And before joining Commerce, he served as the senior energy policy advisor to the great U.S. Senator Tina Smith, who we all love. He also worked for former U.S. Senator Al Franken and at the U.S. Department of Energy. At Commerce, he has been a central figure in bringing federal clean energy funds to Minnesota and standing up new energy programs across the state. So as part of this industrial electrification webinar, we are really honored to have some introductory remarks from Pete. So with that, I'm going to turn it over to Pete.
Thank you so much, Leah. So Minnesota is a state that has big goals. We have a goal of net zero greenhouse gas emissions economy-wide by 2050. That is a tall order, as everybody understands on this webinar. If we're going to meet it, we need to work on every sector of the economy. Officially, industrial emissions are 18% of our state's net emissions. Industrial sources, as many of us know, can be some of the most difficult to tackle, but there are low-hanging fruit. And as is usually the case, the key to rapid progress is via electrification. Luckily, the state of Minnesota since 2023 has had a clean electricity standard, so our grid is getting cleaner every year. By law, we will be 100% clean by 2040. The report you guys are going to hear about today identifies a big barrier to industrial electrification. That's a particularly prominent problem in Minnesota. The problem is that gas is relatively cheaper than electricity for many applications. This gap is a big problem in Minnesota and means that decarbonization via electrification is not something likely to just take care of itself. Policy nudges are going to be necessary. For a hot minute, and I worked on these policies with Leah when I was in Washington, D.C., the federal government stepped forward to provide those nudges via the Bipartisan Infrastructure Act of 2021 and the Inflation Reduction Act of 2022, which provided tax credits, grants, and low-interest loans that were all deployed to reduce emissions. And studies suggested that those incentives would be enough to bend the industrial emission curve. My favorite grant during that era was to Kraft Heinz to decarbonize the Velveeta and Cheese Whiz plant in Minnesota. $170 million for what was billed as the Delicious Decarbonization Grant. But as we all know, the feds have done an abrupt about-face. Many of the grants and tax credits are gone or on their way out. Delicious Decarbonization, sadly, was revoked. But the problem, of course, remains, and we need to find a way to give those nudges without a helpful federal government. We in the Minnesota Department of Commerce Energy Division are working on the issue in concert with Five Lakes Energy. So is the Minnesota Pollution Control Agency via their own commission study and a surviving $200 million IRA CPRG grant. And we're working with other agencies on an industrial decarbonization group convened this year by the governor's office. So this study and this webinar today are all very timely. And I'll turn it back to you, Leah.
Thanks so much, Pete. I liked your concrete real-world example of that factory. And it's sad to hear it's not moving forward yet. But as you point out, the problem has not gone away. So someday we will make that progress again. Our next introductory speaker is Kate Knuth. She is the climate director at the Minnesota Pollution Control Agency, where she not only manages the agency's climate change mitigation and adaptation operations, but also coordinates across the state agencies to implement Minnesota's climate action framework. So a really important coordinating role. A former Minnesota state legislator, Kate has helped advance landmark climate and environmental legislation, including bills that addressed greenhouse gas emissions reduction goals and identified hazardous chemicals in children's toys. Very important. Somebody needs to be thinking about that. She has also served on Minnesota's Environmental Quality Board and as Chief Resilience Officer for the city of Minneapolis. She holds a doctorate in conservation and brings over 2 decades of experience in public service, academia, and community engagement to her work on climate and action in Minnesota. So with that, please welcome Kate.
Thank you, Leah, and thank you to the 2035 initiative as well as Fresh Energy. I am very excited to learn at this webinar, and I've perused the report. And to me, it is another sign that there is increasing interest in building momentum to have decarbonization unleashed in the industrial sector. So my colleague Pete talked about some of the things I was going to mention. Again, a reminder, 18% of the total emissions for the state of Minnesota in the industrial sector. That is the fourth largest sector. But of note, it is the largest sector that has seen increases since 2005. So the challenge has been getting more difficult since 2005, which is the baseline year that we use in the state of Minnesota for our carbon neutrality, getting to carbon neutrality by 2050. So we have work to do there. And not surprising to this group, it's mostly burning stuff for heat. And so dealing with the heat challenge, part of the big challenge in the building sector too, is we need to figure out how to have heat or better use heat or better move heat around, better create heat without burning a whole bunch of stuff all the time. And so we are taking that on. And I think the thing that I want to highlight for this group as you're thinking about this in the overall context, the numbers around some of this work can be, if you look just at the numbers and the lines, a little disheartening at times. And when I think about, you talk about that 20-year career, back in 2007, I was in the legislature when we passed a 25% clean electricity standard. And we blew all of that out of the water. We made faster progress, even though we hemmed and hawed, could we go that fast? And I think the electricity sector, with a 50% reduction in the state of Minnesota, that didn't just happen because we thought it was a good idea. It happened because of policy change, because of private investment, because of research that improved the technologies. It happened for a whole host of reasons. And we need to apply that same kind of thinking with different specifics into the other sectors. And in particular, today, we're talking about the industrial sector. And the thing that I'm excited about is I do see that momentum grow. We have the pullback on the federal incentives and policies, which I think Pete talked about. But in Minnesota, we see and we have an increased focus on the industrial sector in the climate action framework. In the goal 6 in the clean economy sector, there's much more discussion about industrial sector emissions reductions. There's actual businesses who are building and growing to figure out the challenge of heat, and actually not just figure out, but get it implemented. And I think about geothermal companies, heat pump companies, Minnesota businesses that are doing this work and set to expand and really interested. So we see it in the private sector. We also see it in our focus across state government. We have groups that have been, we have a group working across multiple agencies with collaboration focused on the One Minnesota goal area process, but also we are investing planning dollars into what we call a deep dive on industrial innovation or decarbonization, which we think will help align and make clear the path forward. And we see it in grant focus. If I can put things in the chat, my team at the PCA holds the center of our big Climate Smart Food Systems Initiative grant, and we have 2 RFPs open right now for industrial decarbonization. One is for technical assistance and planning, just over $7 million, and one is for implementation. It's a $40 million RFP, and they're for this work in the food system. So as you'll see in the report, the food system is a big deal in Minnesota. The food part, the food manufacturing is a big part, and beverage is a big part of the sector overall. So those are really exciting pieces of movement, I think, setting up the groundwork to take that transformative leap. So I'm excited to learn with all of you today from the folks going deep on some key parts of making the progress in this area. And thank you all for being here and nerding out in this important but sometimes opaque industrial innovation / decarbonization space. So I'll turn it back to you, Leah.
Well, thank you so much, Kate, for your leadership and great comments. And hopefully today we will make it a little less opaque, a little more clear. And
Yes.
With that, Brandon's going to provide some broader context before we really dive into the report findings. So take it away, Brandon.
Yeah, thank you, Pete and Kate, for those wonderful introductions. I think you did a great job teeing this up and covering that industrial emissions are a major target for improvement in the state, and that a large portion of those industrial emissions are related to fuel combustion for process heat. So again, this study was built to identify opportunities for advancing electrification in order to provide clean, efficient heat to those facilities. And I think Pete as well did a good job touching on the diverse portfolio of emissions that we have from industry. We have over 8,500 different industrial manufacturing facilities. Both Pete and Kate touched on the fact that we have, as a whole, around 18% of our state's emissions coming from industry. This map gives you a little glimpse into the location of some of those highest point sources for emissions. And facilities that use low to medium temperature process heat are where we're seeing the earliest pathways for electrification. Alternatively, operations like iron mining and processing, things like that that require higher heat and are generally more challenging to electrify, those are going to be later considerations. Again, where are those low-hanging fruit opportunities? And I'll let Eric and Leah speak more on this, but the new report identified, again, within that food and bev space, some of the soybean, beet sugar, and ethanol manufacturing subsectors, those have the most favorable economics for electrification while accounting for significant emission reduction opportunities. And again, why electricity? Why electrification? Well, Pete touched on it. Our 100% clean electricity by 2040 law makes it pretty clear that electrified technologies present a clear pathway to emissions reduction within facilities. And you all touched on some other really important mandates and programs that the state is building traction from. Really love the Climate Smart Food Systems program and a lot of other opportunities that we can leverage for success. And I don't have time to highlight each of those, so I'm glad that we got to touch on those a little bit briefly. This isn't a complete list in front of you, but just making the point that Minnesota has a very supportive ecosystem, and a lot of people have been doing great work to begin. And there's also a widespread understanding that we not only need to reduce emissions, but there are economic development and labor opportunities and additional benefits from reducing reliance on fuel imports. Now, how do we rank in comparison to other states that are tackling this transformation? Well, this map compiled by ACEEE, this tracks planning and deployment of two primary electric heat technologies, those being industrial heat pumps and thermal batteries. And as a nation, we're still early in this journey, but you can see some of that momentum building for deployment. And unfortunately, this map is a bit out of date. The one pin you can see there in Minnesota was that delicious decarbonization program with Kraft Heinz that Pete touched on. And unfortunately, a casualty of lost federal funding in 2025. Whether or not they're pursuing funding elsewhere, I can't speak to that. But that just brings up the point that, despite the supportive ecosystem that we have here, we're currently not seeing meaningful adoption of these electrified industrial technologies. And that's understandable for now. Again, we're early in the game, but how are we going to truly encourage deployment moving forward? And even for operators that may have sustainability goals and targets or a direct desire to modernize and electrify, there are still hurdles that need to be overcome. So how can we work together to create that landscape that pushes and pulls those folks along and encourages adoption? And one of the things I really appreciate about the newly updated climate action framework is that it calls out an important and unfortunate truth, which is that we are not currently on the pathway to net zero by 2050, and we need to make some serious changes to get there. So that requires significant policy and regulatory reform, and it also requires investment. And another new pollution control agency study notes that those proactive investments are necessary and fiscally responsible because the cost of being reactionary significantly outweighs the cost of investing now. And it's also important to note that we're not operating in a vacuum. A number of other states are actively tackling industrial emissions, and we can look elsewhere to understand what's working, what kinds of policies are moving the needle toward adoption, and which ones are likely to fall flat. Fortunately, last fall, the 2035 Initiative published their national level report, the Clean Heat Climate Opportunity, and that provides a great understanding of the unique challenges that states face, but it also highlights the most approachable pathways that we can be pursuing. So it's been really exciting to work with Leah and Eric and Nate and the entire 2035 initiative team. Their thought leadership has been really helpful. We appreciate their desire to chart out tailored policy and regulatory solutions that can help us move the needle here in Minnesota. And with that, I'm going to hand it back to Leah.
Thank you so much, Brandon. I think you really laid out the context here so clearly for all of us. And so now we're going to jump into the report findings. The first thing I'm going to share is a way that you can download the report if you'd like to. You can obviously take a picture of this with your phone if you're on a computer and somehow have a phone, or you can obviously just do this later too. But this is the report. It's called Advancing Industrial Electrification in Minnesota. And I want to give a shout out to the team who worked so hard on this, including Nate Mariano, Eleanor Thomas, Olivia Quinn, and of course, Brandon Isaacson from Fresh Energy. It's been a great partnership to work with folks in Minnesota. So what are the key findings of our study? Well, the first thing is that the industrial sector and targeting low and medium temperature process heat, which I'm going to get into in more detail, has a big potential to cut pollution. So we're talking about 62 million metric tons just in Minnesota alone. And this would come from electrifying key heat sources in the food and beverage, pulp and paper, and chemical sectors. So this represents a 66% reduction in in-scope process heat emissions through 2050, and it provides massive health benefits, right? Because when we are burning fossil fuels, as we know, it creates particulate matter and other air pollutants that harm human health. And so there's a lot of reasons to do this. I suppose $77.2 billion worth of reasons. One of the big things we try to do in our work is help narrow in on what technologies might be best positioned to move first. And as Kate previewed, those are things like soybeans, beet sugar, and ethanol manufacturing in the case of Minnesota. And those emission savings, from an economic perspective, can be thought of as below $100 per metric ton of CO2 equivalent. Now, as one of the challenges, as Pete mentioned, in Minnesota, it's that there's a high spark gap between electricity and gas costs. What does that mean? It means that if you just keep burning on-site fossil fuels, natural gas, to, for example, run a boiler at a factory, that is cheaper than replacing it with a heat pump or an electrode boiler. And we're going to show you how much cheaper. But of course, policy can step in here, as Pete discussed. So if we, for example, have electricity tariffs that incentivize people to electrify, just like we do in the residential sector with electric vehicles, right? We say if you get an EV, you can have a different electricity tariff. So that's something that we can think about. And the other thing is that if we incentivize high temperature heat pumps with energy efficiency, that's when we start to see the best economics, the lowest increased demand on the grid. Energy efficiency at the plant level can really help pencil out these economics. And there are other important ways to think about how we can manage load on the grid as we electrify these facilities. These are things like thermal energy storage that can draw down, extra power in the middle of the day when renewables are very plentiful, and then use it at times when the grid is dirtier or more constrained, as well as geothermal, which allows for direct heat generation rather than using an electric technology. As we know, and as Kate mentioned, industrial manufacturing requires heat, right? So when we are making things in Minnesota, whether it's, beet sugar or cheeses or anything in between, it requires heat, both for the upstream steam production as well as for downstream processes, things like dryers, for example. They're often direct combustion dryers. Low to medium temperature process heat, which you can see here, we're defining in the sub 300 degrees centigrade range, so in these blue colors. The good news is that that represents 77% of manufacturing heat demand in Minnesota. So it's not like in this particular state, there's a massive amount of higher temperature heat. Of course, it's about a third. Well, no, not quite a third. It's about, let's say, a fifth of the heat. But that means that we can work on the other 4/5 for now, like Pete was talking about, right? We have the technologies we need for this low and medium temperature process heat. And as Brandon pointed out, the goal needs to be to deploy them, even if there are going to be other industries that might be more challenging down the road. So when we're looking at food and beverage, pulp and paper, and chemicals here, You can see here a map that is similar to the one that Brandon showed of where the largest facilities are. And when we had good data from the federal government, this was all reported through the greenhouse gas reporting protocol that they are, of course, trying to dismantle, because if you can't see it, then it doesn't happen, I suppose. But the interesting thing is that these are facilities happening across the state in lots of different sectors, which means that there's a lot of opportunity to try to work on electrification. So what are the technologies that we're actually talking about that are commercially available to electrify low and medium temperature process heat? Well, they're things that you've probably heard of, like heat pumps and electrode boilers, and maybe things you haven't heard of, like resistance ovens, which basically just means an electric oven, induction cooking and sterilization, UV sterilization. So basically what we can do, and what Eric is going to talk about in more detail, is understand how a plant operates today and what machines are burning fossil fuels, and then understand how those machines could be swapped out for clean electric alternatives. And there's so many technologies already commercialized today. And so why should we do this? Well, there's a lot of reasons. It creates cleaner air for local communities. It helps Minnesota meet those goals that Kate and Pete were talking about, and Brandon. It creates an opportunity to leverage advanced manufacturing technology and create a leadership position. As Brandon showed, it's not like there's other states way out in front of this. This could be an opportunity for Minnesota to really lead. It creates economic competitiveness when you have, for example, carbon border adjustment mechanisms on goods. So if you're manufacturing something and you can show that you did it in a low carbon way, that can make a big difference. And it's going to support resilient domestic clean energy supply chains and high quality jobs for American workers as we work to upgrade these factories through electrification and energy efficiency. And with that, I'm going to pass it over to Eric to really get into the weeds here.
Thanks, Leah. And it's my pleasure to get into the weeds because we have a lot of interesting modeling work that supports our conclusions. But our key question is, what we want to do is look at where there are opportunities that are technologically and economically feasible to begin electrifying industrial process heat today. So, of course, we need solutions for high temperature processes. Of course, there will be other technologies to eventually reach net zero. But as Brandon mentioned and Leah also supported, we need to get moving today. So in our project, we focused on 4 major technologies. So as Leah showed in the previous slides, there are numerous electrified technologies that are on the shelf today that could be rolled out. We focused on 4 technologies that hold a lot of potential for Minnesota and also are ready to go today. These include, in the top row of this figure, 2 primary ways of making steam for the plant, either a drop-in electrode boiler. These are boilers that have been around for a long time. They're essentially drop-in replacements for natural gas or other fuels. And on the right, an emerging class of technologies, high temperature heat pumps, which are being proven out today, which instead of combusting fuel or using electrical resistance, they move heat from a source outside the factory into the process to create heat in a much more efficient way. On the bottom, we also looked at key downstream technologies in typical industrial plants where we're using natural gas or other fuels to create heat for baking or ovens or for drying and so forth. We have electrified solutions for those unit processes as well. So we also looked at industrial ovens and industrial dryers as technologies that are ready to go to begin moving the needle today. And because there's no one size fits all for any individual plant or state or sector, we also wanted to look at a range of different possibilities. So what you're seeing here is a list of scenarios that we considered in our modeling efforts and which you'll see play out in the results as we present them. So the key is we want to compare everything to today's technology setup, mostly running on natural gas and natural gas-based technologies. And we categorized our technologies into 2 primary buckets. The first is drop-in solutions. And again, these are solutions that are essentially one-to-one replacements of the equipment that's already there today. And then we also considered more advanced solutions. And that's primarily the use of high temperature heat pumps because they are a little bit more complex to install, require some re-engineering of some of the plant processes. And if we go from top to bottom in the table, you'll notice that what we're doing is we're raising the level of ambition, but also adding in energy efficiency. Because when you upgrade an industrial plant, it's a great time to also go in and update the technologies, update the installation, update the control systems that minimize the amount of energy required in the first place when you replace a natural gas technology with an electrified technology. And you'll see the power of efficiency in some of the results that we show. So one challenge with industrial decarbonization has always been that manufacturing can be quite complex. There's no doubt about that. But we don't have to let complexity be a barrier to identifying smart policies. So in our project, we are taking a pretty detailed engineering approach to quantifying the opportunities for electrification in the sectors that matter in Minnesota. And the way we do this is we develop what we call process archetypes. And you're seeing a picture of one here for beet sugar manufacturing, which is fairly prominent in Minnesota. If you're a process engineer, you'll understand these sort of diagrams really well. And if you're not, I'll explain them now. Essentially, what we do is we want to look inside the plant to understand how you actually make the product. What are the key unit process steps? What temperatures are required? What types of fuels? How does one process relate to another? If you take the time to model a plant in this sort of detailed bottom-up fashion, it gives us a lot of power to look at different technologies. Next slide, please, Leah. So in this particular example, you've seen two unit processes turn green. This is where in the model, we're swapping out a natural gas boiler or a natural gas drying unit with electrified options. And if we can model the systems in this way, we can capture any sort of process interdependencies. We make sure that you're still able to produce the same amount of product. We can calculate new temperatures and so forth. In short, what this allows us to do is have a really rigorous basis for our recommendations. And we can acknowledge that these plants are complex, but we can also show that we've modeled those complexities and that our results are taking them into account. Next slide, please. So we can also employ heat pumps. Next slide, please. As well as swapping in those technologies. But the other really, I think, strong advantage to this approach is if you can capture the energy and the mass flows and all the unit process technologies and their efficiencies, it also gives us a sandbox, a virtual sandbox, to look at the potential for energy efficiency. So using this modeling approach, we can look at a whole range of efficiency upgrades that could occur in parallel as a plant electrifies its core processes, including things like improving process controls, reducing heat losses, optimizing steam traps. Each of these is a variable in the model, and it allows us to show the power of efficiency for the sectors in question. And so we've done this for all of the sectors that you see here. So we're not just treating chemicals and pulp and paper and food and beverage as abstract sectors that all look the same, right? Each of the bullet points here requires its own detailed set of models, which we've done, so we can really pinpoint opportunities at the level of a beet sugar manufacturing plant or a wet corn milling plant or an ethyl alcohol manufacturing plant. Next slide, please. So by doing this, it also gives us a way to quantify just how much low and medium temperature heat could be decarbonized through electrification today in the plants that exist in Minnesota with typical processes. And so what you'll see here is the Minnesota chemical sector does have quite a bit of potential. In fact, most of the heat required in those plants is low and medium temperature. That's the left-hand graph. All the way over on the right for food and beverage, there's a little bit smaller opportunity, but still quite large for electrifying low and medium temperature heat. But I'd love to draw your attention to the middle here. So in the pulp and paper industry, this is an industry that relies a lot on combined heat and power and process integration, and they burn a lot of biogenic fuels, so wood waste and black liquor and so forth. In this report, we didn't try to tackle those sources of fuel use for low and medium temperature process heat because they're a little bit harder to decarbonize, but we wanted to shine a light on their contribution to emissions in Minnesota so that we didn't oversimplify for that sector. But moving forward, those end uses can be electrified. It just means we have to think about process integration and combined heat and power and what to do about potentially stranded byproduct fuels. So I'd love to step you through some of our results. So here in the first graph, we're looking at all three of the major sectors rolled up to the highest level. And what you can see from top to bottom is we're going from baseline total energy demand for these plants. And we're looking at our drop-in scenarios and down to our advanced electrification scenarios with maximum efficiency. So Few key findings. First is efficiency can really make a big difference. So what you're seeing with the yellow bars is how much of the fuel could be replaced through clean electricity. And you'll notice that the bars are also getting shorter as we add efficiency in. So there's a dual benefit here. As we move for any of these sectors towards more advanced electrification with maximal efficiency, we're requiring less energy in the first place, and we're able to electrify quite a bit of the unit processes and replacing some fairly dirty burning fuels like fuel oil, natural gas, and potentially even coal in the food and beverage industry. Next slide, please. And we also have to take into account that the grid is not a static entity. So we look out to 2050 with our models, and we take into account the grid decarbonization plans that Minnesota has, which are quite ambitious, to show that if we start on the left, what we're seeing is the baseline emissions today by running on fossil fuels. And it's acknowledged that if we electrified everything today, unless we can maximize the efficiency, you may see an increase in greenhouse gas emissions only in the short term, though, as the grid continues to decarbonize, which is critically important. Suddenly, those grid investments pay off. We've electrified the plants, and you can see that as we move from left to right, emissions substantially drop. So electrification with clean grid transition is going to save a lot of CO2 emissions in the state. And it also has pollution co-benefits. So in this graph, we're highlighting that we also looked at criteria air pollutants as part of our analysis. We did a lot of detailed modeling about emissions at very local scales, NOx, SO2, and PM 2.5. Compared to the baseline scenario, it's a win-win. We're saving lots of critical pollutants as well. The only outlier is SO2 in the very short term until the grid decarbonization catches up. And then lastly, these human health benefits really save a lot of money. So there are tremendous human health co-benefits. So by electrifying these low and medium temperature processes, you could avoid billions of dollars in cumulative health effects out to 2050, 20,000 days of work lost that would be avoided, 100,000 plus asthma attacks. These come with real human health benefits that should also get strong consideration alongside carbon and other benefits to Minnesota and to these industrial plants. Back over to you, Leah.
Thanks so much, Eric. That was really helpful. I'm going to just finish up our results here by talking about the economics of electrification and what that really means for policy design in Minnesota. So as we've been mentioning, electricity costs are a challenge here, right? But when we look at what we call advanced electric technologies, which is basically those high temperature heat pumps, the economics work out a lot better. So yes, they're still going to increase costs when we look at them, but they're a lot more efficient. And so they're going to use less kilowatt hours in order to make the same amount of heat than an electrode boiler. This is really parallel to what you see in the building sector when you know about building decarbonization, which is that a resistance electric heater is far less efficient. It's like an electrode boiler than a heat pump or an industrial heat pump, right? So that is really the point, that you can save a lot over time by reducing your electricity costs if you go with high temperature heat pumps. The Minnesota spark cap, as we've been saying continuously, is a barrier to industrial electrification. And as Pete said, this isn't all just going to happen on its own. Right now, the industrial rate is about 9 cents a kilowatt hour in Minnesota. And what we show is that it would need to be about half that to be around 4.5 cents a kilowatt hour to really have a break even rate. And that's under an optimistic scenario. Our optimistic scenario is when we assume that heat pumps don't cost that much and you can install them easily, right? If we take a more average or conservative scenario, the electricity prices need to be even lower. So thinking about how we can create a beneficial electrification rate, like a tariff at a Public Utility Commission in Minnesota that would allow these customers who choose to electrify to get a lower rate, just like we let those EV owners do it, is, I think, a really important priority to think about from a policy perspective. That being said, we always want to look for opportunities today. And here again, we show the optimistic and the conservative scenarios. And we basically show that when you look at those high temperature heat pumps, those industrial heat pumps, and you combine them with energy efficiency, looking at the top right circles in this graph here, you can see that things like ethanol and beet sugar, they start to be in the money, and they have pretty big emission savings too, because the size of those circles shows you how big the emissions are. Soybeans as well. But that is an optimistic take, right? If these technologies end up being more expensive, and we of course look in the literature to try to make estimates of how much these things cost, and so we create a range here, like an uncertainty range. So it could be that they end up being more expensive too. But those are perhaps sectors to really think about as early actors, things like beet sugar, ethanol, and soybeans, for example. So when we look at the policy scenarios that we model here, we think about the business as usual case, right? Where you have no policy support. And what we find, unsurprisingly, is that that isn't going to cause a lot of industrial electrification. Then we look at policies that try to reduce the upfront CapEx investment, which is like the policies that Kate talked about from that federal grant that's targeting the food and beverage sector in Minnesota to help companies say, hey, I want to electrify, let me help you do that with some upfront capital costs. If we were to have a new federal government and a new Congress, things that could be on the table, for example, not at the state level, but at the federal level, would be things like an investment tax credit or a production tax credit. That would be on the production OPEX side, but an investment tax credit that could help with the upfront costs. And there are states like Colorado who are already doing these kinds of policies. And there can also be grant making programs that can go for up to 100% of the cost. New York State has been doing things like this. We can also think about the operating costs, and that's where it's really important to focus our attention in Minnesota because of the spark gap. And that's why I've been talking so much about a reduced electricity rate. We look at the data and say that it probably needs to be about half as high per kilowatt hour. So from 9 cents down to about 4.5 cents to make it pencil out for these factories. And federally, again, there could be opportunities. For example, Senator Martin Heinrich from New Mexico, who is the ranking member of the Energy and Natural Resources Committee, has a lot of interest in a clean heat production tax credit. So we look at what that would do. And of course, you can do both things. You can help with the upfront capital costs, and you can also help with the operating costs. So what does that look like in practice? Well, again, using our optimistic scenario here, you can see that no policy, it's pretty hard to have projects be in the money, right? From a net present value perspective. And especially if you take a more conservative case in terms of how much it's going to cost, it's really, really hard. Doing an upfront capital CapEx program up to 30%, again, doesn't move the needle a lot just because the spark gap is really the big driver in Minnesota of those cost differences. If you combine an upfront capital, grant program or tax credit at the state level or federally of something like 30% with a 25% drop in the electricity tariff, then you start to see some stuff come into the money as a break-even point. But even if you were to just do the one thing that I've been talking about, which is cutting that electricity tariff for industrial consumers who have electrified in half, you can see that that really does start to move things into the money. And if we were to have a future Congress that passed a bill like the one that Senator Heinrich has been working on, that production tax credit for clean heat, you can see that that would put a lot of projects into the positive range. Now, of course, upfront costs vary by technology, and so policy support is really needed. So if we look at the no policy, if we compare, it to a gas, like let's say you just have a boiler and it dies and you have to replace it with a gas boiler. So that's that dashed line. So that's what we're comparing it to. You can see that putting in an electrode boiler actually is not that expensive, right? It's pretty much the same. But putting in those heat pumps has a very large range, and it's a lot more money from a CapEx perspective. If you had a program at the state level to reduce CapEx by 25%, it would definitely put electrode boilers, which have that operating cost penalty, into the CapEx money, but then you'd pay for them a lot in the kilowatt hours over time. And something like a 50% program would really bring a lot more projects in. And you could also think, as we've been talking about just trying to get some demonstration projects going by doing something like a 50% or 100% CapEx support program. Now, of course, this is going to increase grid demand, right? And we have many other things that are stressing our grid demand right now, like electrifying the transportation sector and, of course, data centers and AI. But it's our view that this is an essential thing to add to the grid, right? We want to continue to manufacture goods. It's really important for jobs. We need these goods as a society. Let's just make them cleaner. And the way we can do them is adding them to the grid. So we need our planning processes to start understanding where these facilities are located and what new additional load they're going to be bringing to the grid, and be thinking through how we can design these retrofits such that they don't add as much to the grid. And that's using things like thermal energy storage, or even traditional battery storage, although that would be more expensive, or geothermal when it's available, because that obviously reduces the amount of grid demand. And now, one thing I want to really leave you with, that even as we talk about the spark gap being so problematic, it's very important to understand that fuel costs are not a big proportion of total production costs. So if, for example, we look at producing 1 pound of cheddar cheese, if that costs $5.98 right now, if you were to electrify that plant, we would only increase that cost by 2 cents. So it would go up to $6, right? For soybeans, if it's $310 to make a ton of soybean meal, it goes up by $2.17. And for ethyl alcohol, which is a commodity, it does go up by more. So it would be like 9 cents on $2.16 for a gallon of ethanol. So that's perhaps a larger share. But the way to think about this is this a commodity? Can this company absorb some of these costs within, their production? Because adding 2 cents to a pound of cheese is not really that big of a deal in terms of how we think about this. So it is possible that some companies with ESG goals, right, who still believe in that kind of a thing, could move forward anyway, because they think, you know what, we can absorb this 2 cents, because fuel costs are just not a big input into the production process for a lot of processes. I just want to raise your attention to the fact that these heat systems are ready to deploy. Brandon showed a map, I believe from ACEEE, that shows some of where those facilities are across the country. Just want to highlight a couple that we talk about a lot in the food and beverage, pulp and paper, and chemical sectors. So Nile Systems, for example, is working on a lumber drying heat pump dry kiln, and is saving a lot of energy. And that's happening in a bunch of different states. There's a facility under production in upstate New York for ethanol that's going to use heat pumps, including waste heat recovery heat pumps, and in the future, industrial heat pumps as well, like an air source high temperature heat pump. And then our favorite is New Belgium Brewing in Colorado, which is using an air source high temperature heat pumps. And some of the main companies that make these technologies are Atmos Zero and Skyven, and they're out there, really trying to create a pipeline of new projects. The last thing I will say, and then we're going to have opportunity for questions. So please feel free to put your questions in the question entering chat thing, or if you really can't find that, you can put them in the chat and we will have time for some questions. But the last thing I really want to draw your attention to is that earlier last year, we did publish a report looking at geothermal as a solution to low and medium temperature process heat. And of course, there's been so much attention on geothermal right now. Fervo went public yesterday, for example. They're a geothermal electricity generating company. But the thing is that if you have a geothermal electricity plant, it turns out that you can basically use the heat waste stream as extremely, extremely cheap heat as an input into, for example, an industrial process. The challenge is, of course, co-location, making sure that these things happen in the same way. And there are examples around the world, like in New Zealand, where pulp and paper processes are done in a place where there is geothermal, and that waste heat from a geothermal power plant can be used. There's also a garlic drying facility, and I always get it wrong, but I think it's in Nevada that does this already. So the takeaway here is that Minnesota can and must and should electrify industrial processes. How can the state go about this? Well, it's not going to happen naturally, but it can happen with good policy. It's things like beneficial utility rate structures for clean industrial heat for those companies that choose to move forward. It can be those grants and loans like the one that Kate talked about in the climate smart food systems. And that is open right now for organizations that want to move forward. Integrating industrial electrification into cap and invest plans is something that I know Fresh Energy is very interested in. Supporting electrification in integrated resource plans and future of the gas docket. So making sure that we're really planning for this new load in our electricity system. And I think such an important and it sounds kind of fuzzy, but it's actually quite important is knowledge support for facilities interested in electrification. So often in all parts of our lives, we can just do the same thing. We think, oh, I always did it this way, so I'll do it like that. So a plant could be coming to the end of its industrial boiler and just be thinking it's going to replace it because that's what they think they can do and not really understand that there are these other technologies out there. So, for example, in places like Pennsylvania, the governor is working to convene companies, convene heat pump manufacturers, and really share that information as a sort of matchmaking process to try to find companies that want to electrify and companies that can help them electrify. And I think that's super important. We did make an interactive web tool for our national results that, of course, you can zoom in on the great state of Minnesota and click on any of these facilities and really understand them. And I think that's important to understand, okay, what might the economics look like here? And, help people think through how to move forward on these projects. And with that, we're very excited to take some questions. So I'll invite the panelists to come on video and I will go to the Q&A. And I have a question from Drew Harper, which is, was there an analysis, and please, other people, find the Q&A and put your questions in there. Was there an analysis to determine if it would be more cost effective to encourage vehicle electrification rather than incentivizing ethanol electrification? So this is a comment and a question that we get regularly. We are not ethanol advocates by any means, but our decision making from an analysis perspective is that we have to take the world as it is with the pollution today as it is, and we have to model how those facilities could be electrified. If people do not believe that ethanol facilities should exist, that is a valid position, but it is not what we're doing in this report, if that makes sense. So that's pretty much what I would say, like outside the scope of what we're trying to do. What we are trying to do is an engineering, techno-economic analysis that is credible for plant operators and policymakers to help them make decisions about electrifying a given plant. It is very valid to ask questions about the system, and obviously both Eric and I and Brandon all spend time thinking about the system that creates pollution. But that is not what we're doing in this specific report. I don't know if Eric or Brandon want to say anything else. Otherwise, I've got another question teed up. Okay, so the next one is Timothy Rudnicki. He says, when you speak of cost, I don't hear about the cost of burning fuel, the cost to our climate and its impact on insurance rates. So those things are what we are talking about when we talk about cost. We are talking about things like you could think of the social cost of carbon. You could think about how we value health benefits. So the slide that Eric talked through where he showed up to $7.2 billion just from the conventional air pollutants. So yes, those are absolutely costs that we value and discuss throughout the report. So people are welcome to look at that. And we don't get into the relationship to insurance rates. If we wanted to do an analysis like that, what we would have to do is look at emissions, push those through probably like a general equilibrium or climate science modeling framework, then look at how much that increases warming, and then make some kind of assumption about how that then impacts, and then how that drives up insurance rates. So you can see that that would be like a pretty technical and additional analysis that would involve a lot more modeling. And the answer wouldn't necessarily be that credible in terms of like, here's a direct link from a factory in Minnesota all the way through insurance rates. So it is true, of course, that climate change drives up insurance costs, but again, a little bit about our outside of our scope. Anything Chris or Brandon want to jump in there?
Yeah, I would just point again to, and I only had one brief slide on this, but PCA just in March presented to the legislature the Climate Adaptation and Resilience Cost Study. So that very much kind of tries to capture the cost of inaction versus the cost of proactive solutions and quantifying that massive gap between inaction and annual adaptation costs. And it's much broader than industry, but a really good resource there.
Great. We've got a question from Chris Fraughton at Atmos0, a great company making heat pumps. So we appreciate your work. And Chris says, did you look at the value of flexible electric assets? And I'll ask Eric to answer this one, of flexible electric assets to the grid. For example, the ability to send excess renewables into steam systems or unload electric technologies and move to gas when there is a grid event that needs more generation, like using a virtual power plant. Eric, you want to do a first cut of that one?
Sure. That's a great question. And the quick answer is we're working on it now. So the first step in this overall project was to model the plants, understand the role of different technologies, assess the cost, the technical feasibility of electrification, and understand if there's an opportunity there. But you're absolutely right. Like in the future, electrifying some of these core process heating unit processes could also bring benefits to the grid if you can shift schedules, operate them when there's more renewables, potentially store energy on site when you have more renewables, send electricity back through storage. That's something we're considering now in our current phase of work, but it all starts from this foundation that we've built up in the current report.
Yes, totally agree with Eric. We're very interested in things like load shifting because that changes when you have a big new load on the grid, how that load can be managed. This is a parallel conversation to how people think about data centers or AI, right? If this load can be flexible, that can really help with grid planning. And so things like thermal energy storage, this virtual power plant concept of being paid, for example, to ramp down demand at times of grid constraint. These are ways that all this new load can be managed a lot more effectively. Another question comes from Cameron K, which is, what can an individual actor, one who doesn't work in the manufacturing industry, do to accelerate the decarbonization of this sector? I'm going to let Brandon take the first whack at that one.
Yeah, I mean, I think there's a lot of different ways to engage. First off, supporting the folks that have been working on this for a long time. So, engage with Fresh Energy and the ecosystem of advocates and continue to work with us to learn and promote these solutions and get in front of your legislators and work together to again create this ecosystem to move together. And there's a lot of different ways to get involved in processes. Thinking like on that last point from Atmos0 there, we have multiple PUC dockets in the near term, just on the horizon, thinking about thermal energy storage, large load tariffs, some of those considerations that are open to the public to engage in.
Yeah, I will just say that partnering with an organization like Fresh Energy, and there are other ones in the area like Five Lakes. I'm going to mess them up. Maybe Brandon can tell us some more organizations, but that is the way that you can really amplify your voice and increase your impact because organizations like Fresh Energy have relationships with legislators. They know when the legislative session is happening and, they can help you plug into efforts and work. And there can be things like writing your legislator that you can do. Or if you want to take a much heavier lift, really getting involved essentially in a campaign. I think one thing that we hope coming on the backside of this report is that there will be opportunities next year in Minnesota to think about introducing bills that do some of the things that we are talking about. So, for example, directing a public utility commission to create a beneficial electrification tariff. And it can be really exciting and fun to get involved in work like that to make a difference. And certainly what I do on a day-to-day basis, even though my day job is technically being a professor, I still do a lot of this kind of campaigning work, largely right now in the state of California where I live, but you can actually make a massive difference. And that is basically what my book is about that comes out, how everyday people can change policy. And all of us who have talked today have had that personal experience. You see most of us have PhDs. It's kind of funny, but we wouldn't think of us as some ivory tower people. We're involved, we're getting things done, and that is because we are working in partnerships with other groups. So finding ways that you can do that, whether as a volunteer, whether as part of your job, can really be a hugely rewarding and fun and challenging experience. So I just really encourage people to find ways to plug in, and I'm sure Fresh Energy is a great one-stop shopping option. All right, well, we've come to the top of the hour. Thank you all so much for joining us. We hope you found this interesting, inspiring, provocative, insightful, all of the above. And I just want to send, lastly, a big thank you to the folks at Fresh Energy, including Joe and Brandon, for helping to organize this webinar, and to all of you for coming. And I hope you all have a wonderful rest of your day.
Thank you for subscribing to our podcast. You can stay up to date on Fresh Energy's work at fresh-energy.org or follow us on social media. Mark your calendar to join us next week at our Loggers and Legislation gathering to unpack the Minnesota legislative session on Thursday, May 21 at 5 p.m. at Urban Growler. Registration is free and your first drink is on Fresh Energy. You can support Fresh Energy's work to drive bold policy solutions to achieve equitable, carbon-neutral economies in Minnesota and beyond. Head over to our website for the latest news from Fresh Energy and to make a donation. Thank you to the band Palm Psalms for providing our theme song. It's called DGAF, and it's off of their album O2 Haka. Get the latest from the band at palmpsalm.com.